Hello everybody, welcome to my channel. Today we have an amazing problem for you guys. We're going to be talking about delete node and return forest, right? This is a very good problem. So let's see what it's all about, right? So it says given the root of a binary tree, right? Each node in the tree has a distinct value, right? After deleting all the nodes, right? After delete all nodes with a value into delete, we are left with a forest, right? A disjoint unit of trees, okay? So return the roots of the trees in the remaining forest, right? You may return the result in any order. Okay, so very, very good problem statement, guys, right? So we're given the root to a binary tree and also a to delete, right? Which contains values that of the nodes that we need to delete, right? And after doing the deletions, right, we're gonna be left with a bunch of different binary trees, right? Which is what they mean by that, right? We're left with a forest, a disjoint unit of trees. Okay, so our job is to return the root nodes of all the different trees, guys, right? Because we're gonna have a bunch of different trees that are not connected anymore, right? And that's what we need to return. We need to return the roots of those different trees that we end up with. Okay, so the first example, this is the pretty easy example to see, right? So we're giving this binary tree, right? We have one nice binary tree. And after doing the deletion, right, after removing 3 and 5, we are left with 3 different binary trees, guys, right, forming a forest, right? And that's where we return the root nodes of those different binary trees, guys, right? It's the same example here, okay? So that's kind of what the ask is about, right? We have one binary tree and we have nodes to delete. After doing the deletions, return the root nodes of all of those different trees, guys, right? Okay? That's kind of what we need to do, right? So let's go to my drawing board, right? To start, brainstorming ideas of how to go about it, guys, right? So to just make us visually see what's going on, guys, right? This is the binary tree that we're given. And after removing 3 and 5, we end up with, so after remove 5, right? So we have 1, 2, 4, right? And that's why 1, 2, 4, right? 3 is not in there because, guys, right? We have to remove 3, guys, right? After removing 3, right, 6 and 7, they're left alone, right? They're not connected to this tree anymore because 3 is not there anymore. 3 was the only the node connected to this one, right? And because we removed 3, right, we are left with 6 and 7 forming their own binary tree, guys, right? They're all alone. Okay. So this is what's going on, right? So what kind of approach do we need to do, guys, right? Do we need to do kind of traversal do we need, right? Do we delete the nodes after deleting them, right? Do another traversal to capture the root nodes, but how will we do that, right? We will need to somehow maintain reference to the nodes, right? That to the root nodes that the new root nodes, right? That gets formed after deleting the nodes, certain nodes, right? Two traversal, I think will make sense here because we remove 3, right? We need to make sure that we don't lose reference to 6 and 7, guys, right? That's what it's important to make sure that we are being very careful with how we're doing the things that we're doing right now, right? So that's not gonna work out. Okay. Let me see. Maybe what I'm thinking is we can just do reference search, how reference search help, right? Level by level. Maybe layer by layer. No, layer by not gonna be very useful here, right? Can do things recursively, right? Do depth search. Maybe how depth search help. I think there's a lot of different ways we could go about it, right? We can do we can check for each node, right? We can check if it needs to get deleted, right? To maybe pass in parameter to their children, right? To let them know that their parent node, right, uh, is being deleted, right? Since it's being deleted, then those nodes, right, if they're not going to be deleted, they will become new root nodes of their own subtree, right? To become the new root nodes, guys, right? That right? So we can pass in parameter to our children, right? And our children will make decisions based on that, right? So we say that since I'm being deleted, the parent tells the children, right, it's being deleted. So if you're not being deleted, then you are a root node, right? So just add yourself to the output, right? Because you are a root node now, because uh, you won't have a parent that will be referencing you anymore, right? So that's why we have to do that, right? So another thing that how do I let our parent know as well that we get deleted, right? We can maybe send a signal to our parent, right? Say, all right, your left child, right, is null, right? It's deleted, right? So that's how we're gonna let our children and our parent know that we are being deleted. So no need to references anymore, right? So that's how we could do that, right? That's passing parameters to our children and then returning a call to a parent, let us know that we've been deleted, right? That's one way of going about it, guys, right? And this way is a pretty fair way as well, right? Another way we can also go about is to uh, also we could process our children first, right? Okay, process our children first. Our children is going to check, do they need to get deleted? If they don't need to get deleted, right, then we can return, right? Parent. So if they are getting deleted, then they're going to return null to our parent, right, to let us know that they have been deleted, right? See how we're going to simulate the deletion of those nodes, right, by now referencing them anymore and just by sending them to null, right? That's how we end up deleting those nodes, right? And if our parent's going to make a check, right? If it's going to be deleted, then it's going to just check, is my left child null or my right child null, right? If they're not null, then those nodes will become, right, will become root nodes of their respective binary tree, subtrees, right? So if two would have gotten deleted, right? Let's do three, right? Since three is being deleted, right? So three is being deleted, right? It checks. Is six, is my left child, like, no, right? Was it deleted? No, it wasn't deleted, right? Because remember, we're processing our children first, right? We check. That's why the parent can make this kind of decision, right? We check. Is my left child? No, no, it's not. No. Then therefore, since I am being deleted, right, I will add that to the list of forest of it binary trees, right, in the forest, right. That's why we end up adding six there, right. If three was not getting deleted, right, and because three wasn't getting deleted, so it doesn't need to worry about six would not be would not be able to become a root node because three is still referencing it, right? Since three is not being deleted, right? So that's how the parent is going to be making the checks, guys, right? Check, not being deleted, then my children therefore cannot become root nodes, right? Because I'm not being deleted since they're still being referenced by a parent node, right? But if I am being deleted, then my children have potential to become root nodes if they're not part of the list of nodes that needs to be deleted, right? So that's how we're gonna end up solving it. That's how we go about it, guys, right? Traversal. So I think the code will make a lot more sense. So let's quickly get into the code and see what we got going on. Okay. So this is our function here. What we're gonna do, we're gonna need to have so you know how instead of using this array that's given to us, guys, right? We can what we could do is we can perhaps use a set, guys, right? Because we're going to need a way to quickly, when doing the recursive calls, right, to quickly check if a node needs to get deleted or not, right? We don't want to do an ON lookup in the array, right, to see if that number is in there, right? We could just use a set. Set's going to help us and quickly know if a number is in or not, right? We go for that O1, guys, right? Okay. So we're going to have a hash set to keep track of the list of nodes that need to be deleted, guys, right? So we're going to do a loop. Okay. So we're going to just add all the numbers to set in there, guys, right? So all we're doing. Okay. Get some space for us to work with. Okay. So now that we have that, guys, what we're going to do, we're going to need a list of all the different lists, right? Just call it forest, right? Because that's what we need to return. Okay. Array list. And we're going to use a helper function. That's going to help us in doing the recursive calls, right? So we're going to pass in the set and we're going to pass in the forest, right? It's going to be the list, okay? And after we're done, we're gonna return the results here, guys, right? Okay, so now let's craft our function, right? It's gonna be a list of nodes. So we're gonna take this. We're gonna take the sets, right? Second param. And then we're gonna have the list of nodes, right? All right. So we have if the root is null, guys, right? Then we return null, right? That's the case that we know of, right? And after that, what we're gonna do, we're gonna do a check, guys. This we're gonna visit our left child, right? Left side, right? So we go to our left, right? We pass in the sets, we pass in the force as well, right? And also the right as well. Note that right, set, force, right? Okay. So now we go to our left child, right? Right child, right? And then we wait for those answer, right? And then we check, right? That's when we make the decision right here. Does the set contain that particular node that we're on, right? Does it need to get deleted, right? We're gonna have to delete it, right? We're going to have to check. Does our left child, is it null, right? If it's not null, then we know that this node needs to, be added to the list of binary trees, right? That were, right? The list of destroyed binary trees that we're tracking, guys, right? And we'll do the same check here for the right side as well. Okay. Right. And so after we do that, right, we add our left and right child to the list. We're gonna return to our parent to say, all right, just delete us, right? All right, that's why we end up, we set for each node where we set, the left, right? This is how the parent. So this is for, let's say, for one, right? One will call on the right side, right? And with right side, right? So three needs to get deleted, right? So after three processes its children, right? It sends a null signal to the parents, and that's why we set ones that are right to null, guys, right? That's how we simulate the deletion, right? That's how we delete that node, right? Say, don't reference me anymore. Just set itself to null, guys, right? Okay, so after we do that, we are in good shape. We just return the node, right? If it doesn't need to get deleted, guys, right? So it visits its children, and if it's not gonna get deleted, just return myself, right? That's what I need to do. Okay. So before we do that, right, we're gonna have a check here, guys, right? So if we could do whatever check you want to do. So you could do if we need to worry about the root case, guys, right? The root, right? So if the set, right, doesn't contain the root value, right? If the root does not need to get deleted, right? Then what we're gonna do is to force that we're building, right? Force is a list of binary trees, right? Just add the root to it, guys, right? If it does not contain it, right? If we do not need to delete the root, right? Then we make sure that we add the root as a binary tree, right? So yeah, so I think we're in good shape. Let's press run code, see if we pass this small test case. It should be force. Press run code again. Should be node. Yeah, it was consistent. I don't know why I put this there. Okay, looks good to me. Let's press submit. Awesome, guys. We were able to pass all the test cases, guys. If you guys found value, you guys enjoyed this video, guys, let me know that in the comment section. If you're new here, subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.